All right, this will be the last day we spend in our section 9.3 notes. Here's our last learning target to work on, okay? I can use geometric sequences to model and solve real-life applications. All right, let's start on problem 26. Okay, a company buys a machine for $150,000. These tend to depreciate, okay? So the depreciation rate is 25% per year. In other words, at the end of each year, the depreciated value is 75% of what it was at the beginning of the year. Find the value of the machine after 7 full years. One of the toughest things about these problems is kids will struggle with the multiplier. What should we multiply from year to year to make sure it depreciates? Well, if something's going down, we want to make sure the number is under 1. So let's just say we're dealing with an easy $100. All right, so if that $100 goes down 25% per year, that's $25, right? All right, so if that goes down 25% per year, down 25%, we're left with $75. Okay, so the long way to do this is to multiply by 25% and then subtract it to get the total. There's a one-step process to this, though. Take the 100, multiply it by 0.75 to get us to that result now, okay? So what we want to do is use this value here as our multiplier, okay? So the sequence is going to look like this. This might help you too. Some of you will be ready to go and jump right into the formula. Some of you might benefit from getting the sequence going on all of these applications. All right, so we start off with 150,000 for the machine. That's the first term of the sequence. What's the next one? Well, we multiply it by 0.75, okay? So times 0.75 to get to the next term. And I have that value here. It's 112,500. And then we just keep it going. We multiply by 0.75 again. It gives me 84,375. And this is going to continue, right, until eventually it's worthless. All right, but they're not asking for that value. They're asking for, after 7 full years, what the value is. Okay, so when they're asking for a certain term of a sequence, we know we want to use this formula if it's geometric. And this definitely is geometric. So A1 times R raised to the n minus 1. Okay, so A1, we've got 150,000. Common ratio, as I explained, is 0.75. That's our multiplier to get the next term, raised to the n minus 1. And now we have something we can use to find the 10th year or whatever year we want. Okay, now we got to figure out the n value. It's a little tricky on this one. They're not always this tricky, but you got to think about it. All right, you put this machine into the workforce, and then after 1 full year is here, right? This is after 1 year. Okay, and this is the second term. And once again, that keeps going, right? This value is after 2 full years. And this continues. So this is what you got to realize, right? This is the n value of 1. This is the first term here. This is the second term, and this is the third term, and so on. All right? So our n value needs to be 1 higher than the years. Okay? So after 2 years, we need an n value of 3. So if it's 7 years, we need an n value of 8. All right, so n equals 8 over here for what we want. So a sub 8 is equal to 150,000 times 0.75 raised to the 8 minus 1. Okay? All right, so there's our value. $20,022. We'll round to the nearest penny. Okay? So we got $20,022.58. All right, so when you have your problems on your worksheet today, just slow down, focus on the things you need. If it just asks for a certain year, you're going to have to go find A1 and R. If they say the keyword total, you may have to use the sum formula. You've got to just read for understanding, collect your information, and then plug and chug. Okay? All right, so 27. An investment firm has a job opening, and the first year's salary is going to be $48,000. During the next 8 years, there is a 3.49% raise each year. Find the total compensation over the 8-year period. Okay, so once again, how do we get this sequence going? Sequence, first year, 48,000. Okay, how do we get the next year? What's the multiplier? Now, this is different than 26. 26 is something that's depreciating. Well, this person's salary is appreciating, right? It's going up in value. All right, so just like here, to figure out your multiplier, we take 100% and we subtracted 25% to get the multiplier. Here we just do the opposite. We want to add now. So the multiplier will be 100% of the previous year's salary plus 3.49%. Okay, so our multiplier, the percent increase is going to be 103.49%. Okay, does that make sense? This is just plus minus situation. If it depreciates, subtract it to get your multiplier. If it appreciates, add that percent. Okay, and we use decimals, of course, when we multiply this. So to get the next year, my common ratio is going to be 1.0349. How in the heck did he get that? We just moved that over 2 spots, right? Okay, so I'll just get this going. We don't really need it to answer the problem, but just to kind of see this play out, we got 48 grand times the 1.0349. Enter, and there we go. There's the next year's salary, 49,675.2. 49,675.2. Okay, and then this continues. All right, but what are they asking for? Keyword. It doesn't say the 8th year salary, or we'd be using this. This says the total salary for the 8-year period, including the first year. So this is the first term. We want the second year and third year. There's no tricky end value to this one. It's just going to be n equals 8. Okay, so remember our sum formula for geometric sequences says this: S of n equals a1 times 1 minus r raised to the n over 1 minus r. It's probably on the previous page of the notes. All right, so let's just grab what we need, throw it in there, and then be careful with the calculator. So we want the sum of 8 years. What's the first year salary? 48,000 times 1 minus the rates. So we have 1.0349 raised to the 8th power all over 1 minus r. Okay, remember one of the biggest obstacles of this problem is sometimes problems with the calculator. Depends on where you're at. Maybe you're comfortable plugging all that in at the same time. I probably would recommend just doing this in chunks. You figure out this, then we'll divide it, then we'll go ahead and multiply it last. Okay, we'll focus inside the parentheses first. All right, so let me demonstrate this again. So we've got 1 minus the 1.0349 raised to the 8th power. Okay. All right, you can jot that down if you want. I'm just going to keep it in there, and I need to divide it by this. Careful when I divide by multiple things, though. We're going to need parentheses. Divide by, and if you think you might mess this up, and this is where you might just want to write these individual things down. So 1 minus 0. Okay. So there we go. I have this divided by that. All right, so now I just got to multiply by the 48,000 times 48,000. And this is the total, 434,326. Okay. So we get 434,326.49. Actually rounds this to 50 cents. Okay. All right, so you might be wondering, we saw a salary problem before. Why is this one different? Well, the difference is there's a multiplier. It makes it geometric. The problem in your last quiz was arithmetic. There was a set increase. So here it is. Increasing the annual sales by a set amount. That makes it arithmetic. Okay, so once again, you got to read for understanding. Determine if there's a common difference or if there's a common ratio. All right, that's the key difference. Okay, one more I want to show you here. Let's take a look at 28s. Okay, a tax rebate that returns a certain amount of money to taxpayers can have a total effect on the economy that is many times this amount. In economics, this phenomenon is called the multiplier effect. This is very applicable in what's going on right now with these stimulus checks that the government is pushing out. You know, when an individual gets one of these stimulus checks, the government expects it to stimulate the economy because the people that receive it, they also spend it. So it's explained here in 28. Let's take a look. Each consumer has $2,000 more income because of a reduction in taxes. So the government assumes that each person will spend 70% of this. The individuals in business receiving this $1,400 also, in turn, spend 70% of it, creating extra income for other people to spend, and so on. They just keep doing that over and over and over again. Okay, so that's the idea of stimulating the economy. It's kind of neat how this works out. Okay, so here's what this sequence will look like. Now, here's the key word, too. Spend 70% of this. Okay, so what is the amount spent? So if you got this extra $2,000, are you keeping all of it? Or how much are you spending? Well, we're spending 70% of 2,000. So that's how this sequence begins. Sorry, I already said that a couple times. Repeated myself. Okay, so this person is spending $1,400. That's the first term of the sequence. All right, and then the local businesses are going to, once again, not hold on to all that money. They also are going to go ahead and spend 70% of this. So if I multiply that by 0.7, we get 980, and then this continues. All right, now when they say and so on, this is going to approach zero, right? So all the money spent. All right, so this would be a situation where we want to do an infinite sum. They didn't say find the 10th term or anything like that. It's the total amount spent all the way down until nothing's left. So we're using this formula that we used yesterday. It's an easy formula to use, A1 over 1 minus R. Okay, so sum for an infinite sequence, A1 over 1 minus R. What's A1? 1,400 over 1 minus the multiplier, 0.7. Okay, so we have 1,400 divided by 0.3, which I have the answer here, ends up being $4,666.67. So think about it. Just that one rebate of $2,000 ended up stimulating the economy by $4,000, almost $700. And that's just one person. So think about what that happens to an entire community. Okay. All right. The trick to this problem, so maybe try 29, is figuring out the amount spent. A lot of students want to use the 2,000. Okay. That's an important work. Go ahead. Pause the video and try 29. Okay. Check to see if you had the right A1, because A1 is going to be 80% of that. Okay. And then it continues down to 0. Here's your answer, $4,000. All right. That's it for 9.3. Have a great day.